Alright, so today I want to talk a little bit about what I've been up to. I haven't been flying as much because this is what I call the uCharger, whatever you want to call it. It's a pretty weird name, I think so too, but the goal of this thing is to be a modular and light and efficient portable battery charger for one cell whoops, toothpicks. It could have the option to expand to 2S, 3S, but the goal of it is to be modular and portable. And this is just a very rough 3D model of it, but what I wanted to have is have an XT60 input for power, so you can power it off of a spare quad battery, so 4S or 6S LiPo. Maybe if you have a larger 2200 milliamp one lying around, or even a 6000 milliamp Li-on pack, you could power this off. And these are XT30s. That's another one that I particularly wanted to have because a lot of pilots these days that are flying toothpicks fly XT30s. Additionally, I think it would be nice to have a pH 2.0 connector somewhere along here. However, that'll have to be implemented later on. Right here we have air vents. I think that's more for aesthetic purposes. Either way, these are supposed to be right over here on the side, LED indicators, so charge, not charge, charging, just generic things like that. And I wanted them to be stackable, so you can see there's the female header there, and this is a male header. It would just stack on top of each other, and it would transmit all of the power and charge configuration data from these pins. So going to the PCB design, it's something extremely simple. It's not anything complicated because I've just kind of started PCB design, but I'm using this random chip here, ME4057. I was originally going to use Texas Instrument BQ25606. However, I haven't been able to get that one to work, unfortunately. I think in the future that's definitely one that I will be using. So now, as we go to PCB new, this is a very simple design. Ideally, this isn't meant to be a version of the finished uCharger in any capacity. This is purely meant to test out to see if this chip works. So if we go to the 3D view here, it's very, very simple. We have power in, power out, or V in, and then you connect your battery to there. There's also two LED indicators there. Nothing too crazy. However, I do also want to show a failed design that I did before, and that is one of the versions showing the header design. So I'm going to open project, and I believe it's this one. Yeah, so this one uses the Texas Instruments BQ25606 design, and it's kind of a mess, but as you can see here, we have the header opening, so that'll be a female, that'll be a male, and you can just stack them on top of each other. These LED indicators can go to the side, just like right here, and somewhere along here, we can modify the footprint to accept either a direct wire soldered to an XT30, a pH 2.0, or even just directly solder an XT30 to that. So overall, this project has taken a lot of time because I have been trying to learn KiCad. It's very difficult, but things are looking better. Hopefully in the future I'll be able to use this Texas Instrument chip, but for now I'm just using the cheaper Chinese chip, which it's alright. I think it'll get the job done, but my hope in the future is that I'll be able to have something that charges both high volt cells and regular cells. Because right now, this one is switchable, but the other one is fixed at 4.35 volts for one cell. So we'll have to see. But yeah, that's kind of what I've been up to. Maybe, hopefully, this will help. My hope is that it will help a lot of pilots that like flying micros out there to charge their batteries in a very efficient and portable manner. Because honestly, right now, we don't really have that many options on the market. I mean, I'm using a hand soldered parallel charging XT30 thing, no fuses, no whatsoever, and they're all just being parallel charged. So yeah, hopefully when this does come through, it will be of much help to pilots like me that enjoy flying micro 1S toothpicks, whatever you want to call it.